Hey everyone, Mr. Voikin here. In this instructional video, we'll cover Unit 1, Lesson 1 on prime factors. So, to get started, what is a prime number? Well, a prime number is a number that only has two factors. So an example would be 7. The only two numbers that multiply together to equal 7 are 1 times 7. So it is 1 and itself. Those are the only two factors, 1 and itself. And that works for every prime number, such as 19, where the only two numbers that multiply together to equal 19 are going to be 1 and itself. So in this case, the only two factors of 19 are 1 and itself. Now, the opposite, I guess you could say, of a prime number would be a composite number. And a composite number has greater than two factors. So an example would be the number 28. What two numbers will multiply together to equal 28? Well, 1 times 28, 2 times 14, 3 cannot go into there, 4 times 7, and that is finished. So the factors of 28 will be 1, 2, 4, 7, 14, and 28. All right, well, it's time for some practice, and here are 3 questions. What you should do is stop the video or pause the video, complete the questions, then start the video again to check to see if your answers were correct. Well, hopefully you were successful in answering these questions. You can see number 1, 23 is prime, and the factors are only 1 in itself, so 1 and 23. And the number 48 has a lot of factors. It is a composite number, and the factors are 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. And the list of prime numbers up to 100 is, well, I'm not going to read them all out. You can see them there. But it's important to learn these numbers and be able to recognize them because in the next section, when we're doing prime factorization, that will really assist your success in those operations. Okay, we're going to take a look at prime factorization, and as the name states, that's what we are going to do, is break it down into its prime numbers that will multiply together to equal the number that we started with, which in this case is going to be 336. There are 2 main ways to do this. One is a division table and the other is a tree diagram. And basically, they will accomplish the same task, just in a slightly different way. Now, which method you choose is completely up to you, unless I guess the question states use a division table or a tree diagram explicitly. So let's take a look at a division table, and essentially we're going to take 336 and try to divide a prime number into that evenly. So we can see that 2 can go into an even number, such as 336, leaving us with 168. Again, 2 will go into there, leaving us with 84. And 2 will divide into there, leaving us with 42. And 2 will divide into there again, leaving us with 21. I know that 21 can be divided by 3, leaving us with 7, and 7 can be divided by 7 and leaving us with 1, and we are finished in that situation. Okay, well, with a tree diagram it's the same way, it's just that the structure is different. 2 can divide into there, leaving us with 168. 2 can divide into there, leaving us with 84. 2 can divide into there, leaving us with 42. 2 can divide into there, leaving us with 21. And in 21, we have 3 and 7. So in both cases, we've got 2 times 2 times 2 times 2 times 3 times 7, and that, when multiplied together, will equal 336. So, as I stated, 2 times 2 times 2 times 2 times 3 times 7 will equal 336, and they're all prime numbers. Now, a better way to represent this, because there are 4 2's, would be 2 raised to the power of 4 times 3 times 7 equals 336. Well, just as we did previously, it is time for your practice. So here are 2 questions. Number 1, use a division table to determine the prime factors of 1,892, then express the result in expanded multiplication. And you should use powers in your final answer if you can. Number 2, use a tree diagram this time to determine the prime factors of 2079, 2079, then express the result in expanded multiplication. So as we did before, pause the video, complete the work, and then restart the video again to see and check if your answers are correct. And here are the answers. So breaking it down with prime factorization, 1,892 equals 2 squared times 11 times 43. And breaking down 2,079 using a tree diagram into prime factorization, we get 2,079 equals 3 cubed times 7 times 11. Hopefully this has improved your level of understanding in this lesson and you're ready to move on to lesson number 2.